Hello and happy Friday. I hope you're doing well. I made it back from Las Vegas last week and got to spend the week with my family at home this week, and that has been wonderful. Hope you guys had a wonderful week as well. This is Fridays with Brandon, and this is episode number 85 of Fluke Fridays. And what we're going to go over today is the difference between current and voltage and how we can relate that, or how I think of that in relation to water, both pressure and current flow, or pressure and flow. And I think that if we can understand voltage and current in these more layman's terms, we can understand why we need the right instrument or a different instrument for different tools, and why the industry uses current for certain things and voltage for different things when it comes to measuring, and how we control systems out there in the world. So I've got a couple drawings. I'll spend most of my time looking at drawings and pointing at things, but let's jump into it.
Okay, so what I have here is a printing I found online of a water tower that they pump water up here. It creates pressure on the down, and then that pressure helps deliver all the water to the houses. So when we think about voltage and we think about current, if we think about it in terms of pressure and flow, it can help us. So when I think of voltage, I always think of voltage in terms of pressure. And what do I mean by that? Well, pressure over the course of this pipe at the bottom of the water tower, the pressure is going to be greater, and we all kind of know that. The water pressure would be great for taking a shower in this area, but maybe 20 miles away at the houses, it would not be so good. And you can think about that, like if the pressure was the same all the way through, right, then we could just build water towers in the Rocky Mountains and basically supply enough good pressure to the whole country and not have to worry about water towers so close to us. But we know that through resistance, that pressure is dissipated over time. Well, same is true for voltage in our electrical systems. Over time, the longer the wire, then the less pressure gets to what we're looking for. So the longer the wire, the less voltage gets at the source where the load is going to be. Now, that's on the voltage side, and we'll talk about how you measure the difference here in a little bit, but just think of pressure and voltage. And then on the other side, current. Difference with current is it's going to be consistent for the whole pipe. So if we put a gallon of water or 10 gallons of water into this pipe at the beginning, 10 gallons come out at the other end. And the same is true for if it wasn't water, let's say it was oil. Oil pipelines work on this concept, right? One company puts in 1,000 gallons of oil in one side of the pipeline, they can instantly take 1,000 gallons out of the other. Even though it's not the same oil, they know that if they put 1,000 gallons in, 1,000 gallons come out. And same is true for our water. And same is true for our electric when it comes to current. If we have 10 amps come in, we know 10 amps went out the other side. Okay? So now let's talk about how does that relate. So I've drawn a couple things for us, and let's start with the voltage side. So when we're measuring voltage, we're just going to take test leads, and you'll hear the term hooked up in parallel. That's what you're doing with voltage leads, right? You are just taking a pressure reading, like if these were pressure gauges, you're just kind of testing the pressure here versus here, and you could be on that same line, and depending on how far away you are from the source, you could get different voltages on the same line, / you will get different voltages on the same line if you're far enough apart. Okay? Current is different. Current is going to be the same throughout. And how do we measure current? Instead of just doing a pressure test, we have two methods of measuring current. We can measure it with a multimeter, or we can measure it with a clamp meter. Now, with a multimeter, what you have to do is you actually have to hook up in series. So you actually have to break that wire or break that pipe and you have to gulp all the current straight through your multimeter. And that's why multimeters are fused with a 10 amp fuse, most of them, or depending on the jack, or a maybe it's 11 amp fuse, 10 amp rating, and a 440 milliamp fuse and a 400 milliamp rating. But regardless, the multimeter is going to be limited to about 10 amps that it can handle, because it actually has to gulp all of this flow straight through your device. So we're capped at not going too high. Whereas the clamp meter does a different way of measuring. It actually measures the magnetic wave field around that conductor. So it doesn't care. It can have a much higher current flow range and still be safe, because it doesn't have to actually gulp it all through the inside of it. Okay, so this one you actually have to break the line, hook up in series. This one you're just using magnetic field. Now, another thing of when we understand this concept, it helps us when we get into the control side of things. Some of you guys might be familiar with 4 to 20 milliamps. It's a control system, or 0 to 10 volts DC.
Okay, so with 0 to 10 volts DC, they can use that for relatively short runs, right? Because if you have a long run on 0 to 10 volts DC on a little wire, that voltage, maybe out of the source, the transmitter, or the sensing source, might be 7 volts. But if it has to run several hundred feet, it might be down to 5 volts. Well, if you're at 5 volts and you think you should be at 7 volts, that's an issue when you're making beer or oil, or you're making cookies. You don't want it to represent temperature at 70%, but then at the other end it looks like it's only 50% of the scale. So that's really can be dangerous on those long distance. On the short distance, you don't have enough resistance in the wires to change that voltage, so you're not going to have that voltage drop. So what do we do for the longer distance? We go back to the drawing and we remember the current is going to be the same. Even if it's a small amount of current, even if it's a milliamp, a couple milliamps, that's going to be the same for the entire wire. So you can run that 100 feet or more, and you're going to get that same current flow throughout. So if you put in 4 milliamps on one end, we know 4 milliamps went out on the other end. And that's why we'll use current typically for longer runs for that for the control systems. It's because of that concept that current is flow, and whatever comes in one end goes out the other. So if you're 50% of scale and you're putting 50% of the scale of current in, 50% of the scale comes out at the other end, no matter how long your line is. So hopefully that is helpful, understanding voltage and current and relating it to water, which I think all of us relate to water pressure and flow a lot easier than we do electricity. So that's just a simple way of thinking about it, and it helps me understand what tool is the right tool for the job, whether I need to upgrade to a clamp meter or whether a multimeter would work for measuring current in that specific application. If that was helpful, give it a thumbs up, and don't forget, if you watch at least 3 videos, don't forget to subscribe. I've looked at some of the analytics, and it's like extremely few amount of my return. It's like less than 3% of the people that return and view these videos actually are subscribed. So subscribe, it'll help me, and you guys have a great weekend. Take care.